Hello and welcome. My name is Deborah and I am a business developer at Typhoon Hill. In this video, we will be focusing on the new features and improvements included in the 2024.4 software release for Typhoon Hill Control Center. Join us as we explore more details of what this release has to offer. We are glad to announce that Typhoon Sim, our variable time-step offline simulator, is now fully integrated into Typhoon Hill Control Center. Before diving into this walkthrough, we highly recommend watching our comprehensive tutorial video dedicated to presenting this significant change to the software in more detail. You can access the link through the card or in the description below. In short, this integration furthers the goal of model continuity, meaning that you can now go from offline modeling to real-time hardware-in-the-loop applications and vice versa, with the same software environment and the same model file, streamlining your design, testing, and integration workflow. With this update, two key simulation contexts are introduced into Schematic Editor: the real-time and virtual hill context and the Typhoon Sim context. These contexts help us understand component and feature availability and visibility in the software. One major change that comes with this integration is that all components and features are now visible in Schematic Editor, regardless of hardware or toolbox requirements, giving you greater insight into available functionalities. Visual notifications via icons and tooltips are introduced, explaining component compatibility in both contexts. You can now see the meaning behind the introduced icons in this table. The two main background icons represent the different contexts, one for Typhoon Sim depicting a computer monitor, and another for the real-time and virtual hill context depicting a hill device. These icons are color-coded indicators to indicate component or property availability. A red circle indicates that the component or property is not available in that specific context. A grayed out icon indicates that the component or property will be ignored in that context. A yellow circle indicates that there are missing requirements, which are preventing the component or property from being available. The visual feedback is realized on three levels: the Library Explorer level, the Component Property level, and on the level of the entire model canvas, where new visualization features such as model visualization by context and a redesigned model information window are introduced. This update represents a significant change to the software that bridges the gap in transitioning between offline and real-time simulation. We hope these tools will help you in simplifying complex workflows and transforming how you design, test, and validate your systems. We are happy to introduce a new autosave feature for Schematic Editor model and SCADA panel files. When you're working in Schematic Editor or Hill SCADA, you will see a pop-up showing that a temporary backup file has been created. The backup file will be located alongside the original file, which could be in a TSE, TLib, CUS, or WLib file. However, the backup file will appear only when an unexpected event occurs, such as a software crash. The temporary backup file is automatically deleted when you save or choose not to save the original file before closing it. By default, the backup files have the .back extension. We hope this feature will help you easily save and recover your progress in case of an unexpected event. We're excited to announce two new DC-DC converter topologies in our component library: the Active Clamp Flyback Converter and the Active Clamp Forward Flyback Converter. These new additions are designed with the automotive industry in mind. Certain vehicle systems require low-voltage DC conversion, and we're happy to now support these converter types for such applications. Let's begin with the Active Clamp Flyback Converter. You can find this component in Library Explorer located in the Converters folder. Like with other converter components, you can adjust various settings, starting from generic ones like Control Command Preferences to parameter-specific for the converter, such as transformer parameters. The Advanced tab allows you to choose between global and switch-level GDS oversampling. These two oversampling methods differ in computational cost, which affects the component's weight. The weight of a converter determines how many converter blocks can be run by a single processing core. Thus, selecting switch-level GDS oversampling increases the weight from 1 to 2. The Active Clamp Forward Flyback Converter has a nearly identical tab layout to the previous converter, with one key difference: it doesn't have the Advanced tab. Currently, switch-level GDS oversampling is the only supported setting for this component, so be sure to select a firmware configuration that supports it by checking the device table in the model settings. We are confident that these new components will empower those testing and developing solutions involving these converter topologies, especially for those in the automotive field. We are glad to announce that flexible Ethernet port selection, which has already been available for other protocols, is now extended to IEC 61850 Goose and NMS protocol communication. Fourth-generation devices were designed with communication interface capability in mind, with the HIL 606 offering 4 Ethernet ports and the HIL 404 offering 2 Ethernet ports. With this update, you will now find an option in the mask of these components to select your desired Ethernet port. This is useful if you intend to simulate various communication protocols within a single model across different networks. You can find the Goose publisher and subscriber components in the Library Explorer by navigating to the Communication folder, IEC 61850 subfolder, and then Goose. You can easily configure the Ethernet port in the component properties. In this demonstration, we are using a HIL 606 device, which contains 4 Ethernet ports, and as a result, you'll notice 4 selectable port options in the drop-down list. The MMS server component can also be found in the IEC 61850 subfolder inside the MMS subfolder. You can configure the Ethernet port in the same way by accessing the component's mask. Our goal with this improvement is to enhance user flexibility and expand the number of different communication protocols you can implement within the same model, as is often required in power systems applications, such as digital substations. We are excited to announce that now the calibration process of your HIL devices provides a detailed PDF report after it is completed. The test and calibration processes can be initialized by selecting the Test and Calibration tool in Typhoon HIL Control Center. To perform any of these actions, make sure you're connected to your desired HIL and that a HIL calibration card is plugged into the HIL device. After following the instructions and completing either the test or test and calibration process, you can access the automatically generated PDF report at the folder location shown in the log. In this example, we chose the test and calibrate instead of just testing. The difference here is that the calibration process is also performed after the testing, automatically adjusting gains and offsets. As a result, post-calibration results are also shown in the generated PDF report. As we can see, this report is structured in the following order: general data, summary, test tolerances, pre-calibration test results, and post-calibration test results. In the summary, a brief pass, out of spec, or fail flag is presented for the analog and digital inputs and outputs, as well as the power supply. Pass is achieved only when the measured signal is within an acceptable range and below a defined tolerance limit. Out of spec occurs when the measured signal falls within a specified tolerance range, but does not meet the desired target specifications. Fail is designated when the measured signal exceeds the acceptable tolerance limits. Based on the mismatches, some offsets and gains are adjusted during the calibration process for the analog inputs and outputs, as shown in the post-calibration results. Our goal with this feature is to help you document the calibration process of the Hill device by generating an organized file containing all the relevant information from the calibration process. Thank you for joining us on this release walkthrough of the 2024.4 software release. We invite you to test out these new features in your projects and provide us with your insights and experiences. For more information and updates, stay connected. Thank you for watching.
Check the video description for more resources on this topic, including how to download and get started with Typhoon Hill Control Center for free. You can also visit Hill.Academy to access free courses, expand your Hill testing skill set, and get certified. Subscribe to our channel to get notified about new content.